Morning, this is Ms. Billerbeck, and we are going to talk about 9.4, solving quadratic equations using square roots. So if we have the square root of a squared, that equals plus or minus a, because a times a equals a squared, and negative a times negative a equals a squared, because two negatives make a positive. So when we have an a squared in the square root, we really don't know, is it positive or is it negative? In this section, we're also going to talk about the Pythagorean theorem. If you don't recall, it's a squared plus b squared equals c squared. So if we have a right triangle here with a right angle here, our legs A and B are here, and C is directly across from the right angle. It's the hypotenuse. So let's do a quick proof of the Pythagorean theorem. So if I have two equal squares, they're identical. So that means that they must have the same area. Then I have a triangle, a right triangle, A, B, C. So A is a leg, and I have an A squared here. B is another leg, and I have a B squared here. And then C is my hypotenuse, so I'm going to put C squared right there. So we're going to prove that A squared plus B squared does indeed equal C squared. And I've got all these triangles here that are identical to this triangle. So what I'm going to do is I'll put 4 triangles over here and 4 triangles over here. And so 4 triangles should equal 4 triangles. And then I have A squared and B squared here. So if I put C squared on here and A squared and B squared over here, I should be able to cover all the black area. And if it covers all the black area evenly without any overlap, then they are the exact same area. So that one covers all of this black rectangle. There you go. And then if I make 2 rectangles here, I have 1 rectangle like this. And 1 rectangle like this. And you can see that they do cover the black rectangle very well. So A squared plus B squared does indeed equal C squared. So that's a visual proof of the Pythagorean theorem. It's also an empirical proof. All right, so we have example 1. We want to solve each equation by inspection. So this just means we're going to think about it. So 169, we know that 169 is 13 times 13. So x squared, since x squared is x times x, we're looking for 2 numbers that are the same. That would be 169. So we also know that negative 13 times negative 13 also equals 169. So that means x has the possibility of being a positive 13 or a negative 13. So we're going to say x equals plus or minus 13. Now we look at this, we see we have x times x again, so x squared equals x times x, but now we want to make it equal to negative 16. So we know things that do equal 16 is 4 times 4 is 16. And we also know negative 4 times negative 4, negative 4 equals positive 16. But the only way to get a negative 16 is to multiply negative 4 times 4, and that's negative 16. And these are not the same number. And we can't really have half a negative in the real number system. So what we have is no real solution, because there's no way to multiply two numbers that are identical and get a negative result in the real number system. So let's solve these quadratic equations. So this one, what I'm going to do is I'm going to use an additive inverse here of 19 on this side and this side. And that gives me negative 5x squared equals, and then I have 144 plus 19. So that gives me 13, and that's 6, 3. All right, so when I divide by negative 5, I have a little problem. Okay, so I see on this one, I've got that cancels, so I have x squared equals 163 divided by negative 5, which is negative 3, 2, and 3/5. Okay, so I'm looking at that and I'm like, you can't have a square that equals a negative. So I have no real solution again. All right, so let's take a look at this one. So if we subtract 17 from both sides, and I have 3x squared, that's going to equal, I have 2, then that's going to be a 10 here and a 1 there. So I'm going to have 9 and 192. Okay, I'm going to divide using a multiplicative inverse by 3, that cancels. So I have x squared equals, and then for this one, I have 6 3s and 19. I'm going to carry a 1, and then there's 4 3s here. So I have x squared equals 64. So if I take the square root of x squared, I get plus or minus x, which is plus or minus the square root of 64. So, or x equals plus or minus 64. So x then is going to equal plus or minus 8, because 8 is the perfect square. 8 times 8 equals 64. 64 is 8 squared. So that would be our solution for that. All right. Whoops, these got a little out of order. Oh, well. Okay, so we are going to find the solutions for this. And if it's not an integer, we'll say what it's between. So first, we're going to divide by 5. And then that gives us x squared equals 25. So when we take the square root of this side and the square root of this side, we're going to put a little plus or minus here. So we get x equals plus or minus, and then 25 is just 5 times 5. So the 5s leave the house. So we get x equals plus or minus 5. So that's our solution. Now let's divide this one Well, actually, yeah, we could divide this one by -1/2. So we divide by -1/2, or you can multiply by 2/1. Actually, let's do that. That might be a little less confusing. So I'll rewrite this and we'll write -2/1 times -1/2 x squared equals 36 times -2/1. And that's a -36, so we'll put that there. Okay, so we've multiplied by the reciprocal. Right here. And when we do that, that just cancels that when you multiply by the reciprocal. So we have x squared equals, and -36 times -2 is 72. And we have a 1 there, so there's just 72 ones in 72. So that's 72. Now 72 isn't a perfect square. So let's take the square root of x squared, which is x, and then we're going to take the square root of 72. We prime factorize 72. That's 2, and then we have 36. Well, we know 36 is 6 times 6, so we don't have to prime factorize to the very nth degree on this. So we're going to say x equals, oh, and we can't forget our plus or minus, by the way, because we took the square. So we have the square root of 72. So we have plus or minus square root, and we have 2 times 6 times 6. Now, again, if I did prime factorize, I see I have 2 2s and 2 3s. So 2 times 3 is 6, and 2 times 3 is 6, or 2 times 3 is 6 there. So if I did do prime factorization like this, I would take a similar amount of things out. So 2, 2, 2 times 3 times 3. Right, so I'm going to take the 6's out here, or in this one, 2 and 3 in the prime factorization. So I'm running out of room, so let me grab another board. So this then is x equals plus or minus, and I can pull the 6 out, and then the only one left home alone is the 2. Now down here, it's just going to be the same thing, but just an extra step. The 2 comes out, and the 3 comes out, and then the 2's alone, and it stays home. So that's just plus or minus 6 square root of 2. So either way, you get 6 plus or minus 6 square root of 2. Now, 6 square root of 2 is not between any two. It is between two integers, but it is not an integer. So the square root of 2 approximates to 1.41. So when we multiply that by 6, we get 6, 24, and 8. So this number equals plus or minus, or approximates to plus or minus 8.46. So that means that this is going to be between the two integers 8 and 9, and it also will be between -9 and -8. So that would be the two integers, sets of integers that this number would fall between. All right, let's do the last example. So we want to find the distance from the base of the tower. So we have the tower here, which is X high, and the ground here, which is X. And we want to find the base, the distance from the base of the tower here to the midpoint of the guy wire. So the guy wire is 200 feet and the midpoint is here, then we know that this is 100 feet. And we also know that this is 100 feet here on this side. All right, we know that this is X. So if we redraw, and this is a right angle where this distance is measured. So we can redraw the triangle. Oops, I'm losing my ink. Let's redraw the triangle like this. So I have a section here of 100 feet, and I have X on the bottom here. Well, let's see. Oops, I've drawn it wrong. So the 100 feet is not the hypotenuse. The hypotenuse is X. So maybe I should draw it the same direction so you aren't confused. Okay, so let's take that triangle out. And we have the right angle here. Okay, this is D, what we're trying to find. This is 100 feet. And this is X. So per Pythagorean theorem, C is across the right angle. So X will be C. So we want to find D. And in order to find D, we'd have to find X first. So we have 100 squared plus D squared equals X squared. So we want D squared. So let's subtract 100 squared from both sides. So D squared equals X squared minus 100 squared, which is 10,000. So you just do 2 zeros and then 2 zeros again for 100 squared. Okay, so that means D will be, if we follow the procedure, we do plus or minus X squared minus 10,000. But can we have a negative distance? No, we can't. So there's only going to be a plus. So we don't need to put a plus or minus. All right, so now we know what we need to find, but we also need to determine what is X squared. So from the original triangle, we have X squared. Here, our X here, and 200 is the hypotenuse. So we have X squared plus X squared equals 200 squared. So X squared plus X squared is 2X squared. 200 squared is 40,000. Okay. So then we're going to divide by 2. So we get X squared equals 20,000. So now we have most of what we need, but we just need a little more board space. Okay, so we are ready for the final part of this. We know D equals the square root of X squared, but we know X squared is 20,000. So we're going to put 20,000 in there minus 10,000. So that gives us D equals the square root, and that's just 10,000. And we already know 10,000 equals 100 squared. So that means the distance is 100 feet. So the distance from here to here then is 100 feet. All right, that's it for this lesson. I hope you have a wonderful day. Bye-bye.